Hello, this is Hans Adams from Nishimbo Micro Devices and welcome back to another product introduction video. Today we have a look to a new power management IC. The 1801 is a buck DC-DC converter designed for use in the Internet of Things ecosystem by extracting energy from photovoltaic or piezoelectric cells. As soon as the solar cell receives light, it starts to generate energy. A voltage on the input of the R1801 builds up until it reaches the maximum power voltage level. This is the optimum operating point of the solar cell, generating the maximum amount of power. Now at this moment, the R1801 DC-DC converter starts to operate and transfers energy from input to output. When the output reaches 90% of its setting, the power good output becomes active and enables additional circuits. When the transferred power exceeds the generated power from the solar cell, the input voltage starts to decrease and at a certain moment the R1801 stops switching. At this point the process will repeat again. Step by step the output voltage decreases and accumulates the energy in a capacitor or battery. The power good output remains active until the output voltage drops below typically 2.13 volt, regardless whether the input voltage is present or not. In this way, it keeps circuits on the output active even during nighttime when the solar cell does not generate power. The R1801 has a built-in reverse current protection to keep the energy in the energy storage device and prevents a current flow from output to input. When the input voltage drops below the output voltage, this protection circuit becomes active under the condition that the input voltage is equal to or greater than 2 volt. If the input voltage becomes less than 2 volt, the reverse current will charge the input for a short moment until the protection becomes active again. As a result, the average reverse current will be very small. In this way, the R1801 remains providing power to connected circuits even without power from the solar cell. The output voltage of the R1801 fluctuates a bit since the energy storage device is being charged and discharged and by the load connected to the output. Therefore, another buck-boost DC-DC converter is used to stabilize the supply voltage for the peripherals ICs. The circuit diagram of the R1801 is simple. It requires only a few external components connected to the chip. Additionally, a solar cell and capacitor or energy storage device of your preference. On the right, a list of recommended components for your reference. One significant advantage of the R1801 is that the output and maximum power point voltages are adjustable. It is possible to tailor the settings according to the solar cell performance. First of all, one has to select which product version to use for a project. The product version already has a preset output and maximum power point voltage level. Refer to the left table for details. Secondly, it is possible to adjust these preset voltages a bit by controlling the 3 pins VSET123 and VMP123. By configuring the 3 pins, one selects how much the initial voltage setting increases or decreases in a 100 mV step. The total adjustable range is plus minus 300 mV. Refer to the table on the right. Please note that additional product versions may become available over time due to specific customer requests. Here are the specifications. Note that the R1801 consumes only 200 nanoampere quiescent current and already starts up at 1 microwatt. The graph at the top shows the peak efficiency at about 85 to 90%. The graph on the bottom shows how quickly the output voltage reaches the actual setting level versus different lighting levels, ranging from 30 seconds at 800 lux to 230 seconds at 100 lux.